When we see the oil production facility flare gas, we often misunderstand it as waste. However, this flame represents a critical safety and operational practice known as flaring. Far from being an environmental oversight, flaring is fundamental to the safe, efficient, and compliant operation of complex industrial facilities. Let's explore why flaring is not just necessary, but an indispensable part of the oil and gas industry. First, the ultimate safety relief mechanism. Handling hydrocarbons involves immense pressures within vessels, pipelines, and compressors. If these pressures aren't managed, they can quickly lead to explosions, catastrophic equipment failure, and severe injury. This is where flaring acts as the ultimate safety valve. Flaring allows excess gas to be safely burned off rather than released directly into the atmosphere as raw, volatile hydrocarbons. This immediate combustion prevents overpressurization, safeguarding the entire facility and its workforce from devastating consequences. Second, handling unplanned and emergency events. Oil and gas operations are complex, and unforeseen events like equipment failures, sudden shutdowns, or power losses are always a possibility. During such incidents, the system might need to rapidly dispose of gas that cannot be processed or stored. Flaring provides a fast, controlled, and immediate method to deal with these situations. It allows operators to quickly alleviate pressure and safely eliminate hydrocarbons that cannot be managed by the normal processing train. This capability is crucial for maintaining facility stability and protecting both personnel and equipment during highly stressful and unpredictable scenarios. Third, disposing of non-salable or waste gas. Not all gas produced is of marketable quality. Some streams are heavily contaminated with undesirable components like hydrogen sulfide, carbon dioxide, or excessive moisture. These contaminants can be corrosive or toxic, making the gas unsuitable for sale or reinjection. While advanced treatment technologies exist, they aren't always economically or technically feasible for all waste streams. In these cases, flaring offers the most practical and often the only viable method for safely disposing of these harmful or non-useful gases. It prevents their dangerous accumulation within the system. Fourth, supporting maintenance and startup operations. During planned shutdowns for maintenance or when starting up a facility after an overhaul, gas flows are highly dynamic and often non-standard. Processes are purged for safety, and lines are slowly brought up to pressure. These operations inevitably generate excess gas that cannot be routed to normal processing units. Temporary flaring is used to manage this fluctuating gas volume. It allows operators to control flow and pressure during these critical transitional phases, ensuring the facility can be safely prepared for maintenance or brought back online without risking overpressurization or uncontrolled releases. Finally, ensuring environmental and regulatory compliance. It's a common misconception that flaring is worse for the environment than venting. In reality, the opposite is often true. Raw hydrocarbons, especially methane, are potent greenhouse gases with a significantly higher global warming potential than carbon dioxide. Flaring converts these highly potent hydrocarbons into less impactful carbon dioxide and water vapor through combustion. Modern flaring technologies are designed for high combustion efficiency, minimizing uncombusted hydrocarbons. Regulatory bodies worldwide recognize flaring's necessity and impose strict guidelines on its design, operation, and emissions monitoring, helping facilities comply with stringent environmental regulations.